Welcome to Stay Sharp in Digital Engineering, your insider's edge on all things digital in the world of engineering, products, and manufacturing. In this episode, we unpack the rise of digital engineering and government contracts, what it means for contractors, especially small businesses. From risk management and data rights to collaboration and compliance, we explore how understanding these evolving requirements can help you stay competitive and shape better outcomes. Let's tune in. Welcome back, everybody, to Stay Sharp in Digital Engineering, the podcast about all things digital related to products and engineering, manufacturing, service, and more. I'm one of your hosts, Julianne Grant, and I'm joined today by my co-host, Jonathan Scott.
Hey, everybody.
Hey, Jonathan. Welcome back to the chair.
Glad to be here. Another fun conversation today.
Yes, absolutely. So today we're talking about digital engineering, but from the government supply chain side. So we recorded an episode a couple weeks back on what it takes to get started with a digital engineering program. But today we're covering this part of the conversation. We're going to take a look at the challenges from the side of the contractor who is trying to win business with the government or trying to support their customer as they navigate the new world of digital engineering. So to do that, we have a special guest back with us. I believe it's his fifth appearance on the podcast, Steve Nichols.
Nice.
Woo,
hey, woo! Yeah. You got to celebrate the small stuff, and maybe that's what we're doing.
Steve, yes.
Yeah, you're welcome. Nice to be here.
Yeah, we're glad you're here. So, in the last episode of Digital Engineering podcast, where Steve was here, we gave a proper introduction because I'm not sure we actually did that. But I'm gonna, in case you missed it, I have a few more notes for you today. So, Steve heads up our public sector and defense group at Razorleaf called Razorleaf Government Solutions, and has spent his career leading technology-based groups and organizations, and is very well versed in many aspects of business, including technology support or operations, marketing, project and product management, innovation, and strategy. And obviously, government spin on all of this. He helped form the Razorleaf Government Solutions group about 10 years ago, and to help us be more competitive in securing federal and government contracts. So in looking at his resume, though, I found this nugget very interesting. So as an undergraduate, Steve wrote a thesis called The Study of the Effects of an Electric Field on Agarose Gel by Neutron Scattering, which capped his degree in physics and was an early part of the Human Genome Project. Come on, Steve.
Hey, you know what? You're right. As an undergrad, that's what I did. Now, after kind of a 12-step process to kind of be a little more socially acceptable, that doesn't come up that often anymore. But every once in a while, that little voice does rear its head, and off we go.
Yes.
I'm glad you found that nugget, Julianne. That's fantastic.
Yeah.
I've got all kinds of questions about agarose gel today, Steve.
I don't know what that is. So yeah, let's cover that later.
Yeah. All right. So with that, I'll jump right in, not to agarose gel or, effects of an electric field on neutron scattering, but let's get back to that topic you were talking about, Julianne, kind of, this being part two of talking about this DE in the government, but looking at it from that flip side. So, for those who aren't familiar with all this, we did recap a lot of it in the other episodes. So I'll point you back to that to learn a little more about DoD instruction 5000.88 and 5000.97, because that's what drove a lot of this digital engineering need in the government. But if we take for granted that lots of governments now want to buy systems and products and maybe even some services using digital engineering, what does that mean for industry, right? So that's really what we want to get into today. And, let me just start with a question, Steve. If the buyer, meaning the government, has to use digital engineering, and that's kind of what we talked about last time, does that mean that the seller does too? Is this becoming a requirement to even sell to the government in the first place?
So yeah, Jonathan, the short answer is mostly yes. And to draw that out a little bit, for programs that have a digital engineering requirement to them, the supply chain, the folks that are supplying product, source, data, whatever services back to that contract will most likely have to comply with some portion of that digital engineering requirement. It is going to be contract dependent and where you fall in the contract. So as a prime contractor, if there's a digital engineering requirement, then you're going to have to cover that. If you supply the prime contractor and are part of the supply chain, then there may be components of that you have to adhere to. There may not be, depending on what it is you're supplying to the overall program. But overall, if there's a digital engineering requirement in there, and we're not really diving into the details of what that would be yet, but overall, if that's contract requirement, then you're probably going to have to support it in some method.
So you're selling a tire to Lockheed to go on the F-35. Maybe you have to meet the digital engineering requirement. Maybe you don't, but certainly they do by the time it makes its way back to the customer. If the government said, hey, I want digital engineering on the F-35, that Lockheed will have to fulfill it, but maybe you're making a part you don't.
Maybe. But as the government starts to think about digital engineering, it's also starting to think about other capabilities or requirements that we've heard of before, such as digital twin, digital thread, model-based systems. And so those types of requirements have tentacles that reach out through the contract and through the supply chain, which may require some type of digital integration or digital engineering support or integration. And it's going to be figured out at the contract level. So let's take that tire that you talked about. If you are the tire supplier and the government has a digital engineering requirement, it may look like a part. It's maybe what you end up shipping. But if you're shipping 50 of those, or maybe you're shipping tires over the life cycle of the project, which may be 30 years, the government's going to want to know, hey, where'd that tire come from? How did you put it together? What's the heredity of that tire? Because if they start seeing issues with the tire later on, is that a unique issue for that tire? Are all tires out of a batch, or a lot, or a specific factory starting to show some type of issue? And so having some history of what looks like a benign part still may be a requirement of that digital engineering contract or that digital engineering program. And so even parts themselves, while it may look like a standalone transaction, may have some type of data requirement that goes with them.
So this may sound, self-serving since we're in this space and we live, breathe, and eat digital engineering, but that makes it sound like if you are in the space or you want to be in the space of somehow serving the government or selling parts to somebody who does, you really should be thinking about digital engineering, because the requirement could pop up and it could flow down to you and you might need to fulfill it. So you want to be kind of ready. That's going to make you more ready maybe to serve that need.
I would not necessarily say ready, but I would say aware.
Okay.
And just be aware of some of the areas that you as a company may go after and what some of those requirements might be that you may be asked to discuss. And a lot of things are open for interpretation and negotiation, just depending on where you fall in that supply chain. But I'd be aware of it, because maybe you're always selling a tire, and maybe the requirement that might come along with selling a tire is, hey, we need a list of suppliers and the manufacturing process of what it took to build this tire. Maybe come through as an Excel document that someone else uploads into their to start to build their digital thread. You're the customer that you sell to, who then sells to the government. And a tire is pretty straightforward as far as that. But what if you're selling a radio, right? Historically, that radio might have an input and an output. And you might just say, okay, this is the cable that goes into it. This is where it plugs in the model. This is where it goes out. But now the government wants to know, hey, what's actually inside that radio? What did it take to put that radio together? There's integrated circuits, there's resistors, there's inputs, there's pins, there's a power supply. They might want to have some more visibility into what went into that just for the life cycle of the program. And so thinking about, okay, being aware, what might I be required to supply and what cost might that incur on the government side or the customer side? We should be thinking about something along those lines. We don't have to. I wouldn't put a whole bunch of effort into it, but just be aware to address the conversation should it come up. Don't let it be a surprise.
And you brought up another interesting point when you sort of responded with what might be asked of someone. When you said, "Oh, it could be that you're filling out an Excel spreadsheet and somebody's uploading that kind of thing." I think that's a good reminder that the digital engineering, if we put that in, caps and quotes and things like that, is a pretty broad requirement and could look a lot of different ways to people. So to run right out and say, oh, I have to have a fully 3D, MBD, MBE based enterprise, it's probably a little bit excessive. So your awareness point, I think, is well made.
Right, and that's just it, right? From the prime contractor's perspective, they're probably going to have to satisfy all of whatever that digital engineering requirement is going to be, and keep in mind, digital engineering today is a set of concepts, ideas, and some practices. Over the next 5 years, 10 years, 15 years, 20 years, as technology, as capabilities, and as the workforce evolves, digital engineering is going to look much different. And the requirements are going to be much different. I think they're in their infancy today, but it's going to grow and it's going to evolve. And so you can't plan for 10 years from now. You can support today, but if you're in the conversation and you have the digital engineering mindset, you're going to be good. If you're always looking for ways to kind of, well, I don't think I really need to be there, and so I'm just going to answer the question that comes up, but that's all I'm ever going to do, it's going to be a little rockier.
Well, I'm wondering is, a lot of these contracts, they award some small businesses to be part of this. So how prepared are they to help respond to these requirements? And it sounds like there's some flexibility as long as they're tracking things. I can provide an Excel spreadsheet. But do you ever see some challenges around that? And do you ever foresee them maybe having to adopt different applications to support their place in the supply chain?
So I see a lot of challenges for small businesses, but in those challenges really come a whole lot of opportunities. And so let's take this F-35 example just as a place to start, and we can move that if we need to. If a small business went in and bid on an F-35 requirement of sorts, that small business is probably going to be able to satisfy a portion of the requirement, and then they're probably going to use teammates to satisfy other portions of the requirement, unless it is a amazingly pointed requirement for that program, at which point it might come out as what they would know as a sole source. So this little small business can supply X. X is very specific. It's a sole source. It's the only thing this small business can do, and it's the only small business or business in total that can do this particular service. Therefore, we're going to go as a sole source. Then you wouldn't necessarily worry about it. The government says, this is what we need. This is the company that can do it. Therefore, they do it.
Kind of like the bruschetta I make at home, right? That'd be like sole source to me. Just saying.
You know what? Potentially. And maybe that,
Where'd you
that
get
might
the
be
bread, Jonathan?
Yeah, you haven't had my bruschetta, Steve, clearly.
I assume, are you outsourcing your tomatoes, and are you outsourcing
I got my own supply chain, buddy. You don't ask about that. I'm just saying.
There we
Become
go.
sole source to me on the bruschetta. That's what I'm saying.
I can see another episode coming up already.
Sorry, not to distract.
Yeah. So in thinking through that, right? But if there's a broader requirement that the small business can 100% knock out, and you see this with small business set aside. So the customer will say, okay, here's the F-35 program. We're going to go out and we want this to be 80% large business, probably a prime who handles most of it. And then that prime would say, they would give a requirement to the prime to say, of this award, 20% needs to be small business. So you guys need to go out and figure out how to make sure that of everything, you're the prime contractor, but 20% of the work has to come as a small business. How do you do that? So there are some strategies there. Jonathan, that's a long answer to say, and Julianne to say, from a small business perspective, unless the requirement is amazingly specific, the small business is probably going to go out and find team members that join its team. And so that the small business would reply to the digital engineering requirements from a team approach, would really be a chorus of saying, well, here's the small business as the lead, but then it's got, large aerospace OEM as team member number 1 and 2 small businesses team member 2 and 3. And then it's got a mid-size part supplier as team member 4. And we bring, as the small business, all these capabilities to the table, of which we have done some in the past, and we have team members that do others.
Well, and that could mean all kinds of things too, right? In that teaming, to your point,
of course,
you could be coming in with a technology like an amazing bruschetta, and somebody else is bringing the digital piece, right? And you're putting that together to package it to meet the requirement.
Very much so, right? And that's part of the teaming strategy that businesses will go through no matter what they're doing, right? And you see that a lot on the government side. There's a lot of teaming that happens. And sometimes, a company A will be on this company's team, this other company's team, because that team is priming. And then company A will go and prime on its own and bring the other company on as its team. And sometimes they'll both be trying to compete on the same, and they'll be competitors. That is really typical in the government industry. Is just there's a lot of collaboration where possible, and yet with these capabilities that are kind of unique, there's collaboration, and then sometimes there's competition, and everybody knows it. And it's just natural.
Well, it really kind of speaks to the different kinds of relationships that the entities have with each other and then with the government, if you will. So can you build a little bit more? I mean, you're talking about the teaming relationship, but what about the relationship between the commercial industry and their government customers, for example?
Yeah, and so in some of this, so like I said, projects are contract and program dependent, right? What those requirements are that are going to come out. Digital engineering itself is moving more mainstream. And so we talked about earlier that there's a perspective to digital engineering that is, it's not fully baked, but there's some assumptions and concepts. And we may address an assumption later on in our conversation here. But the mindset is shifting. And so as a supply base, we also need to be shifting that concept as well. And one of the big areas that I think we need to keep in mind is risk. And so from the government's perspective, they don't like risk. And keep in mind, most individuals don't like a bunch of risk either. They're happy to play with it a little bit, but we don't like risk. And government doesn't like risk, and risk is carried liabilities in many different ways. And so when we think about our government partners, customers, partners, however you want to look at it, helping them understand how utilizing digital engineering concepts that we as a supply chain potentially use today, and how we manage that risk so that they adopt our risk management naturally. They don't have to worry about, hey, what are we picking up by liability by driving digital engineering and bringing these folks on board? What liability do they bring to the contract that we're not thinking about? Being able to educate the government customer on how using digital engineering technologies is actually more of a benefit than a risk, and how we do that and how we help them do that and adopt it is part of that conversation, is something we should be thinking about.
So I think you kind of flipped it around, Steve, right? A minute ago, it felt like we were talking about, if you're in industry and, you want to be selling to the government, or you already have a government partner and you need to come up to speed on digital engineering, like, how important is it? Is it critical? That sort of thing. And what you were just talking about seems like it flips it around a little bit. Like if you have a government partner who maybe is getting introduced to this, having to learn and having to come up to speed, but you already have some digital engineering practices yourself, how do you sort of use that in the relationship? How can that help? And that's your point of risk. Am I catching that right? That you're kind of talking about it like from the other situation?
I actually wasn't thinking about it in the other situation. I think it's a spectrum.
Okay.
And so we're thinking about digital engineering as a set of capabilities, right? In industry, we're thinking about, hey, how do we run our business and what's our motivator? And then we try to serve the government and as our customer. And so thinking about how do we support the government to be able to take on and kind of think about these capabilities and being successful with them, I think is that risk management. For a company that doesn't do any digital engineering, and is low tech and I don't think they're bidding on these kind of contracts anyway that have a digital engineering requirement. They're being sourced through another company that's really managing it, and then the company is managing that interplay between the government and whoever that ultimate supplier is, and passing those requirements down. Does that kind of bridge, Jonathan, your question?
Well, I think so. I mean, it sounded like where you were going with that, though, was for the companies that are out there who feel like they do have a pretty good digital engineering strategy or capabilities today, that there's something they can think about bringing back to their government partner, right? And it's what I heard, and again, maybe I got this a little bit wrong, is that when there's a mismatch, either within the team that might be serving the government or between that team and the government partner or customer, that there's value in sort of sharing across, leveling out, hey, here's what we do and why, that kind of thing.
Well, very much so. Digital engineering is success here is really a conversation. The digital components of it are what you're end up delivering and utilizing, but this is a conversation. And hopefully, before a contract comes out and you start bidding on it, you have the opportunity as one of the potential primes or someone who's going to support that to be in with the government to talk about ways that they could be doing digital engineering. So you not only you have their viewpoints on what they feel is success, but you've had the opportunity to be in there to help shape some of what they are going to be looking for in their digital engineering and collaboration components of their program.
Let's dig into that a little bit, right? So what kinds of things could an industry partner be doing in that realm? Like if you were trying to shape, maybe even how the contract comes out or how it might look based on the best practices, like what kinds of things are we talking about? I mean, is it CAD? What is it?
Well, so it's a couple different things. And I think this goes back to, is this a requirement to even sell to the government, right? And I think that's kind of goes back to the question you asked. And thinking about, big programs that potentially have digital engineering sometimes have industry days. And so you have the ability to go to an industry day and hear what the government's viewing, and then having you have the ability to set up meetings with the government to share how you're doing certain things. And so if digital engineering is a requirement for a program that you're interested in, whether you think you're going to be a prime contractor or a team member, a subcontractor to a prime, you have the ability to go in and talk to the government and help share things that you're doing, things that you see are best practices, and things that you think are approaches that they should try to adopt in their program moving forward. You have the ability to really share those types of opinions. You also have the ability to go in and talk to government suppliers, even if it's not an industry day. If you think there's a program coming up that you want to influence, then make an appointment and go see them. You can talk to it as a technology immersion appointment, best practices appointment. If you have a relationship with this particular program already from some other way, then it may be a relationship appointment that you're talking about. Hey, we wanted to show you some neat new things we're doing and how we're doing them that you may be interested in for the future.
Go win friends and influence people.
Yeah, pretty much, right? You can write white papers. And see if you can't put together a couple-page white paper and get it in. There are also what are called BAAs, broad agency announcements, that the big agencies will put out that look at approaches to problems that they're forecasting, and these are approaches across the agencies. And so you can write a response. You can go have a couple meetings with them and share some of your best practices for, in this case, digital engineering, and see if you can't land a couple kind of contracts or concepts that way as well. There are also small businesses, SIBR, Small Business Innovation Research, where the government will pay you to chase down some neat concepts, and that could be digital engineering as well. So there are a wide variety of ways to get publicity for your digital engineering approaches. You just kind of have to think through them a little bit. But going back to, if you're trying to influence a contract coming up, you should be aware of what's going to be in it from a digital engineering perspective and seeing how you align with it.
So that brings up another question for me, Steve. And I know you and I have both worked on some projects where this has been an issue, and it's maybe a pervasive issue with government contracts. But as we talk about digital engineering and companies, sort of sharing their know-how with the government, it makes me think about data and data sharing, and data rights have been an issue. And that's why there's this whole topic of data rights in government contracts. But as we get into digital engineering and a company's product information and IP is easier to share, and the government is more likely to ask for it and need it as part of their digital engineering picture, does this change the dynamic on that tension? And it's, I guess for those who aren't aware of it, let me just spell out what I mean. There is this healthy, sometimes unhealthy tension where the government is saying, look, I want the data from the contractor because they want to be able to support and spare and repair this thing they're buying. But the contractor's saying, wait, no, you didn't pay for that, or I'm going to have to increase the price for you to own that because I was thinking I was going to make money selling you spares or repairs or service or that kind of thing. And there's this natural tension across that. Does this change some of that?
Yeah, very much so. Yeah, it really does. The tension is still going to be there. And in this case, I would say tension comes with a cost, or tension can be mitigated by a cost. And you brought it up to say, okay, hey, I wasn't planning to share my digital engineering model with you, Mr. Customer, because I was counting on, some MRO type activities or some sustainment activities generating future revenue, and therefore giving up this information may decrease that revenue. that comes at the negotiation stage of the contract. And I assume that for contracts coming out, if the government is thinking that there's a digital engineering component, there is some text in there that talks to the requirements of information sharing. And so I would say that there's two focuses here of information sharing. One is information sharing with the ultimate customer, which is the government, which then might impede future revenue for whoever the supplier is, thinking, well, that holding on to that information might be a competitive advantage and allow me to make money selling more to the government in some way. So that's the first, I think that's the first issue that is covered in the contract. The second issue that's covered in the contract is intellectual property spillage with relation to other similar companies in the supply chain picking up company A's intellectual property and their models on how they do this tire that you talked about earlier, whatever the part is, with another company who also does tires, and having that intellectual property spill out into the commercial realm. It's one thing to share it with a customer and have the customer say, well, we want this because it's part of our digital thread. But if there's a competitor to you that's also working in this digital thread, how do you protect your intellectual property from your competition that could be a competitor in the future outside of this particular program? So both of those really need to be addressed. And only one, in my opinion, can you put a price on.
That second one, I certainly remember having this conversation, particularly with DLA, right? Defense Logistics Agency. And I get that that's a challenge. A program says, hey, I'm buying this. We'll go back to the tire example. It's all made up, obviously, but government buys the tire and says, look, I need the recipe for making it because I want to be able to buy other tires in the future from whoever. Well, okay, but if you're somebody selling that tire in the first place, do you really want to provide the recipe so that later DLA can go out and shop that around? And then when they do, and they buy that tire from somebody else, suddenly that supplier says, hey, I know how to make tires in a new and different way because, like you said, the intellectual property was spilled over as it got passed around and handed around. And that's, I think your point is, digital engineering does change that somewhat. It can change that. It can influence how that happens, how it's controlled, that sort of thing.
Yeah, very much so. And I would also say, let's drag that DLA example out a little bit. I don't know that DLA would go out. I'm speaking on behalf of DLA without, having that knowledge. So
I did too. So
right, I'm going to have to throw a disclaimer on here. But I don't know that DLA would go out and say, we want a tire made to this recipe. We'd say, we want a tire that meets these requirements. How you get there is up to you as a supplier. Because when you're bidding on it, if the recipe is part of the requirement, then that's a different approach. But if they just want a tire that meets, life cycle, heat, these measurements, and whatever it happens to be, then they're just going to put out a set of requirements, and the recipe is up to the supplier themselves.
But that's where it's so important to think about all this data, right? Is the easier it is to generate the data, the easier it is for it to get passed around, asked for, shared, all these things, and you have to think about it on the customer side and on the government side.
Well, and it's part of that data flow up front, as planning through thinking about digital engineering. What does it mean for the program? Everybody thinks about the movie style digital engineering where there's a CAD model flowing around and somebody's got some VR glasses on and they're moving it here and they're moving it there and they're kind of dancing a little bit and they see the whole thing and somebody else sees something else and that's great. But that's not what we're talking about. Digital engineering here is really applying a set of capabilities to a digital set of processes and getting an end result out of it. And that digital process has long tentacles that reach way out to pick up value-added pieces along the way and then get those pieces polished and get those pieces met a requirement that then delivers something at the end, right? And so we need to think about digital engineering as that long rope or that kind of long column or that long road, of which part of it is that model flowing around.
Interesting.
Speaking to that, and this is one that, as you were describing things, Steve, just reminds me of a conversation with another partner of ours that we've talked about in the past, that when you are selling to the government or in that supply chain anywhere, it feels like nowadays you have to think about not just the cost of the widget that you're selling or the service that you're selling, but the cost of the digital engineering data that you're providing, right? In some cases, maybe that's simple, but in other cases, if the contract says, look, I'm not buying off on that aircraft without a matching cyber asset, right? That is the digital twin of that aircraft. When we're in that world, I think a lot of these companies need to be thinking about, well, what's the cost of me providing that? I can calculate the raw material cost and everything for the tire I'm selling, but what's the cost of the digital engineering data that I provide with it? Is there a cost? Should there be? Like all those questions. I mean, is that something that people need to be thinking about as they get into this?
Yeah, very much so. All right, because that becomes part of a deliverable. So people think about the physical thing that is being delivered, but if part of the requirement is a digital representation of some sort, whether it's a model, whether it's a recipe, whether it's a process, whether it's a list, we're going to call that digital representation. That's actually part of the deliverable. That's a requirement, right? So there's a physical and a digital part that constitute a deliverable, and that does have a price to it.
Well, I just wonder how many people, if you're saying that this happens, these kinds of negotiations happen at the contract point, it's like, how often do people really know, what the cost of this digital data that you're talking about, Jonathan, is? Like, are they really thinking in these ways now? Or there's obviously a lot of partnership things going on, and you have to be careful about, what IP gets shared. But I just have concern, like, how ready are we as companies to do this?
Yeah, and I would say we're getting there, right? I think some companies have it figured out better than others. They might think about their deliverable as design deliverable with a model and product outcome versus a traditional, we're shipping you a product that we designed last year. And right, and so it's thinking about that. And if they are delivering a product that they designed last year, but they're required to deliver some type of digital artifact with it, what's the cost of that digital artifact? Because it may have been designed last year, but the digital artifact, I doubt, is packaged as per the requirement they're about to get. So someone's going to have to think about packaging it. You're going to think about the cost of that information getting out of your company. Is there a cost? Is there a liability? There may not be, but kind of thinking through that a little bit. And then what does that overhead entail going forward? Do you have if you change your product in the future, do you have a requirement to change that digital artifact, or was that a snapshot in time? Or is that a persistent requirement going forward? And therefore, what might the cost be?
I think that's a really interesting question, Julianne. Because at least speaking from my experience, I think a lot of our customers don't have a handle on what these systems and processes cost them. Right? They think about it during projects. Right? They're going to go implement a new MES, a new PLM, a new ERP. And so that cost gets a lot of attention when it's time to deploy it. But does somebody have an ongoing cost model that says, hey, this is what it costs us on a day-to-day basis to deliver or even create the digital engineering information that we create? That's a tough one.
Well, yes. and Jonathan, it might be, it might not be. It depends what's being delivered, and they may have their total development costs wrapped up as an incremental part of the product they deliver. Right. We got to deliver 400 of these products to break even on development, and on product number 401 or item 401. You know what? That covered our ROI. So it may not be as complex for some of these deliveries as we could make it sound. That may all be just standard product delivery for them. It just has a digital artifact that goes with it now, but they may be just fine in it. It may be wrapped up in the overhead.
Well, it's really interesting to hear all the different variables that go and are involved with a prime type contract and supporting government customers. So it's been an interesting conversation, Steve. But Jonathan and Steve, I'm going to have to say we're close to our time. So I'm going to have to put a bow on this. So Jonathan, what have you come up with in terms of some conclusions here?
Yeah, I've been taking notes. I think, things that I heard in the conversation, Steve, and please, when I get done, jump in and plug the gaps for me where I missed something. But coming back to how we started the conversation, I think you do need to understand a little bit about digital engineering to sell to the government these days. Not every contract, right? But ones where it comes out as a requirement, you want to understand what it is you're signing up for and, not have misconceptions about, it's just give them a 3D model, that kind of thing. And it doesn't mean that you have to go have it all tomorrow. If you're, trying to sell, you're in a supply chain somewhere, awareness is good. It's a good place to start. You don't have to have all the capabilities. And you might be able to bring the capabilities as part of a team. You don't necessarily have to be the one to bring it all. So I think another piece, though, is to think about knowledge sharing as a two-way street, because it could be that you're bringing more, you as an organization are bringing more digital engineering know-how or capability than maybe even who you're selling to or who you're teaming with. So think about that as value you can bring to the table and share with that customer, maybe help shape the requirement of what they're asking for, or how they're asking for it, just to make that partnership stronger. You threw in some alphabet soup of BAAs and SIBRs and things like that. And I won't try and go back to all of it. But the part that I heard there was think about that in terms of shaping, right? Working together, win friends, influence people. If you've got DE knowledge that you could share with your government partner or customer, do that, right? Open the conversation. It could expose your expertise, right? Help them prefer you in some way. Or you could just be doing a service to the overall process and maybe teammates and things like that. I think another piece that really is interesting is that DE can change that data rights tension. Maybe not sway it one way or the other, but it can certainly influence it. So think about it as you're thinking about, how do I share my data with the government? What are they asking for? Can I provide that? How do I price it? That kind of thing. It changes the dynamic a little bit, or it can, and it's important to think about. Don't forget, when you are thinking about that, how to price this out. How do you come up with the cost yourself? And then how do you price out those deliverables, right? So it's one thing to price the product that you're selling to the government and say, look, this tire is going to cost you X. But it's another to think about, what are the DE deliverables they're asking for? And how do you price those out? And how do you justify that? So as you get into these capabilities, it's something to think about to know how you're going to factor that into your pricing and your costing. Those are the things I heard. What did I miss though, Steve?
Yeah, I think one thing we didn't talk about would be, we talked about DE as kind of a place where information goes in. We didn't talk about kind of integrations. And so we talked about a supplier potentially donating or not donating, but providing information into someone else's digital thread. But there may also be a way for their digital thread to encompass your systems as a supplier. And what might that cost as well? I think that comes out in the negotiation with the prime contractor or whoever happens to be leading this. But the digital engineering environment might encompass your systems as well, in a way that benefits the whole program. And so just kind of keep in mind that may be another approach, is there may be a reach in versus you pushing out.
But it's a good don't forget part, right? Like I was talking about, don't forget what it costs to provide these things. Well, but it might be to integrate these things, not just provide them.
Right. And there may be a value add there too. If you're a smaller business and you're not necessarily looking at the prime position, but you're looking as a subcontractor and thinking about how do you add value to the overall program, being willing to open up some of your digital capabilities to that type of integration, not just sharing the data, but being willing to open up some others, even if there's a price to it, and be looking like you may be a little more forward thinking on digital engineering and a little more flexible in your approach, may win you some friends that others might not be willing to do.
Very good. Wow, gentlemen, we are definitely at time, and we want to respect our listeners' time for listening to this conversation, which has been great. So thank you so much, Steve. This has been wonderful.
Yeah. Good stuff.
And of course, Jonathan, it's always good to have you and your thinking in these conversations, because you always ask great questions.
Thank you.
You're welcome. So I learned a lot today. I hadn't quite factored in all the different elements that are involved when you're dealing with government contracts and trying to work digital engineering into, and how that's kind of proliferating everything in terms of how business is done for government. So quite interesting. So with that, there's plenty more ways for us to dive into this topic. And I'm sure we're going to cover more things later and have Steve back, I'm sure, at some point in the near future. So we'll always leave that door open for you, Steve. We love having you.
Thank you.
Thank you. And if anyone has any questions for Steve or wants to talk more about the digital engineering factor in government, please reach out to us, make a comment on the post, send us an email at podcast@razorleaf.com. We'd love to hear from you. So with that, we hope everyone have a great afternoon, and be sure to listen to future episodes with us. And until next time, everybody, stay sharp. Thanks for being here and listening to this episode of Stay Sharp with Razorleaf. If you like this podcast, please be sure to hit that like button. We'd really appreciate it. And don't forget to subscribe to our podcast on your favorite podcast platform or on our YouTube channel. If you have any questions, be sure to leave us a comment on this post or send us an email to podcast@razorleaf.com. Till next time, everybody, stay sharp.